Chatlier Lab. Okay. Maybe I'll split this one out. When I process it, I'll split this one out and put it next to the lab. Okay. So get some light on that subject. And that off. Go. All right. Let's mute this. Oh. Oh, I see what it's doing. There we go. Okay. So this is pre-lab for Le Chatelier's principal lab next week. And there are 4 pre-lab questions. So I don't need to go over the principle of Le Chatelier's because we covered in class pretty well. But we're going to be looking at different ways to stress a system and watch how it responds. So what do we mean by a stress applied to an equilibrium system? What is a stress? Okay, I'll entertain ideas. Right, does it have any in the discussion? A stress. Actually, a stress is anything. Right, anything done to an equilibrium state of a reaction. That causes a response. That's what I would say. How does an equilibrium system behave when a stress is applied? Causes a response to mitigate the stress. So if we add a reactant, it's going to consume part of that reactant until equilibrium is reestablished. Or if we remove a reactant, it's going to shift back toward reactants until equilibrium is reestablished. And equilibrium is defined by the K value at a given temperature. Okay, how about 2? Given the gas phase reaction, so we've got this gas phase, sulfur dioxide plus oxygen is in equilibrium with this product, sulfur trioxide. So they're all gases. And what are we going to do to it? Suppose that the reaction has already taken place and the system is in equilibrium. So at equilibrium. If the following changes are made to the system in equilibrium, tell what effect these changes will have on the system, whether the equilibrium shifts to the left, to the right, or not shifted. Okay, since we have an equation to work from, we can say right and left and we know what it means. So A does what? A, add oxygen. Which way is it going to shift? Go to the right. Yep. How about B? What are we going to do? Sulfur trioxide is removed. So we remove product as soon as it forms. Shift to the right again, don't we? C, pressure of the system is decreased pressure decreases. So how would we do that? Well, we increase the volume. When we decrease the pressure, is there a difference between the moles of gas? 2 plus 1 is 3 versus 2. So if we decrease the pressure, it's going to make more, going to try to make more moles of gas. It's going to shift to the left. Right? And D, a very efficient catalyst is added. What happens? No change. Okay. Let's see, turn the page. 3. Explain why the solubility of a sparingly soluble salt represents an equilibrium system. Okay, that's the first system that we're looking at in this experiment. Is what we have is sodium chloride is going into solution. Okay, so we're saying that this solid is being dissolved. So how is that an example of an equilibrium system? Well, actually, is that the best way to write this? Yeah, that's okay. If we're at saturation, that means you can't put any more of this in solution. So what's actually happening? Well, this is dissolving, but this is coming back at the same rate. So if you have some solid, sodium chloride down here, and some sodium ions and some chloride ions up here, they're going backwards and forwards at the same rate. Now, this is not a sparingly soluble salt, it's very soluble. But we have reached, in our experiment, we have reached equilibrium. Right? The solution is saturated. So what happens if we add more sodium chloride to the solution? Nothing. It's already at saturation. So why is it representing an equilibrium system? Equilibrium is always based upon rates. So the rate of this one is equal to the rate of that one. The forward rate and the reverse rate, dissolution and precipitation, are exactly equal in rates, in speed. That establishes equilibrium. I should have said that at the beginning. That was 3. How about 4? Might not be able to do 4. We're talking about phenolphthalein is used in this experiment. Right? It's an indicator, an acid-base indicator. So phenolphthalein is in basic solution is pink, or depending on how strongly it is, it could be pink, it could be actually approaching violet. But in acid solution, it's colorless. Okay. use an encyclopedia to find the formula of phenolphthalein. So you got to find the formula. I'm going to let you guys do that. Formula. Right. So it'll have carbon, hydrogen, probably some nitrogen. You just write the formula, whatever it happens to be. And what pH range gives you a change from this one to this one? So what you want to know the pH range. Where does it start to change and where does it end? And you can get that. It's okay. You can go to Wikipedia and get that one. I've been there, and it's a valid. Some wiki is just a load of crap, but sometimes if you go in with your eyes wide open, you can usually tell when they're trying to jerk a chain. Okay, those are all the pre-lab questions.